What is going on, guys? My name is Hussein, and in this video I want to discuss 5 methods of authentication. So guys, authentication is the process of verifying your identity by supplying some sort of a credential to a backend, and the backend will try to know who you are and verify if you actually, okay, this guy is Rick, this guy is Paul, this guy is Hussein, right? Versus authorization is the process of actually, we know who you are, we know you, Paul, but are you really authorized to access this resource? So that's a little bit of a difference. So I'm going to explain the authentication, and not only one method, one or two, 5 methods. The first one is no one in their right mind should even consider using it, right? And the final one, the 5th one, is actually only the paranoid using it. So where are you in the spectrum? We're going to explain all these methods. All right, guys, I have here a very bad user experience that simulates this stuff in the HTML because I'm not Brad Traversy. I'm very bad in the front end, but it does the job because it has some text box. There is a login button and there is a register button. Login will attempt to send a post request to log into a backend, and we're going to go through that process. And register will actually also send a post request, but it will register using this username and password, right? So it will insert something in the database. How about we actually go on the backend and explain that stuff? So my backend here have 5 MJS, Michael Jackson files, right? And each one describe a certain method of authentication that I'm gonna go through in details. And as I start describing these methods, you're gonna see some time codes. You can jump to the interesting method of authentication. So the first method is, upon registering the username, we will store the password as plain text. Yes, guys, we gotta go through all the bad methods, even if they are bad. All the methods, we have to explain everything, right? Storing the password as plain text and verifying it using just simple query to the database. The second method is a little bit better. We're gonna hash the password and store the hash in the database. A little bit of better, right? So someone in the DBA, for example, or if the database is leaked, nobody can see the passwords, but there is also problems with this. We're going to go through that, right? And the third method is, well, we're going to store the hash, and alongside it, we're going to add another column called salt, right? And this is a little bit of a better method, right? But we'll explain why it's better and why the method 2 is actually not that great. But this is also another better, but we had to pay extra price to actually store another column, right? Method 4 is one of the most popular, is to use bcrypt, which kind of also salted password with a hash, but the salt is stored in the hash itself, so we don't need that extra column, which is also cool. We're going to explain that, and we're going to go through the code. And the final method is for the paranoid. Never actually store the password at all, right? And rely on the user to supply the password to access anything, right? So everything is stored encrypted in the database, and not even the owner or the DBA can actually see what's going on, right? Previously, all of these methods, right, the DBA can actually still query the database and look through the data, right? Because it's all there, right? But the 5th method is actually, no, everything is encrypted, and only the user specified password, he or she can encrypt or decrypt the content to actually view it. If they lost the password, that's done. There's no recover from that. How about we go through all of these methods, guys? So the first one is store the password in the database as a plain text. Let's go through the actual columns in pgadmin so I can show you. And let's just query authentication method 1. I have 2 fields, username and password. They are just text fields here. Okay, and what we're going through here is just like, this is very simple thing. We're creating a pool of number of connections by default when we start the database, and we're sending the HTML file. Maybe we'll go through the HTML file, which is the login.html, that page that you saw. There is a post request that performs the login, and when you send me the JSON file, which is the username and password, right, I will literally query authentication method one table where username equal this and password equal this. The plain text password, just query in the database, get back a result. And we know if we got no results, that means either the username doesn't exist or the password is incorrect, right? Or both. And just send an error back. Else, send back and login successfully. How about register? Register. So first of all, we need to check if the user actually exists. So I'm going to query the authentication method one table where user equal this, and let's just provide the username that the user supplied. And if we don't find anything, that means yes, we can actually create the user because it doesn't really exist. Go ahead and insert into the authentication method one username and password, just plain text, just write it down to the database, and else we get an error. Okay, how about we show you the login file for once, and the HTML file will stay identical for all the methods. The only change we're gonna have is actually the backend. All right, so we have an HTML file where text, username, and the login and the register. And we're wiring some events here so that if I'm logging in, this is the login button. I want to, if someone clicks on that, I want to send a post request to the login page /login, right, guys? That's the /login. That's what we called it, right? And then this is what we send. Method post, headers, it's obviously a JSON, and just send the username and password as a JSON so we can pick it up. That's what we saw here, right? Request.body.user, request.body.password. Sweet. And the register is exactly the same, just we change this to /register. So just post, right? Cool. We know the HTML. We know the backend, the first method. How about we actually run it? Authentication method one, boot, run, sir. And the table is now empty, obviously, because there's nothing in it. Let's go ahead and create a new user called test. And the password is also test. And register. We get user created successfully. Query the database, and we have a test. That's bad, obviously, because everybody can. If this database got leaked, like Equifax happened, everybody will have the password, right? I'm not saying Equifax had the password as plain text, but there are some problems with this. And there's very bad problem, right? You never do this. And if I log in, let's hit a login. I'm logging successfully. If I type in wrong password, incorrect password and username. Sweet. How about we create another user, Paul, and the password is test123, because that's the best password ever. Look at that, user created successfully, and if I log in, I'm gonna log in successfully. Boring stuff, right? Moving to the next method, which is the hash, right? We close this. Now we're authentication method 2, and let's discuss this. So what we're doing here differently is everything is the same except when we store, let's store the register. When we are registering, the only thing we're doing different is we're hashing this using a method called SHA-256, right? This is a function that takes some text and create a hash, one-way function, right? So what we're doing here is insert into Auth Method 2, which is another table, the username and password. And the password here is the actual hash. So we're not really storing the actual password, just the hash of it, which is unreversible. You cannot just reverse it. So take the body, user, hash it, store the hash, and say it's successful, right? Else, we get an error. All right, login. How do we log in? Well, same thing. We're going to query the database, but here's where we query for. The only difference in the query, we're querying for the hash. So whatever the user sent us, we'll hash it and shove that in the database as a query. And if we got something, that means it's successful, else no. How about we run this? Run. And we'll see what's wrong with this in a minute. So refresh this. We're gonna create a user called, let's query that method 2 here. There's nothing, right, in the second table. If I log in, if I register as test, the password is test. Now we get this hash. A little bit better. This is just garbage, right? Nobody can actually use this and log in, right? Even if the database got leaked, right? But let's create a user called Paul, and the password is something else, Edmond, right? And a query. Ooh, this is working. This is actually pretty good, huh? Some hash. How about we actually log in? Well, I can log in successfully. Let's create user Rick, and his password happened to be also test, right? Register, query. What? Oh, that's shady. Look at that. Username test has the same password as username Rick. Huh, right? So that is just a bad idea in general as well, because obviously, the actual table will not just have two fields, right? There will be like a hint field, right? And people put all sorts of stupid hints in their password, like, yeah, oh, password, usual password, or oh, test, oh, my pet, or yeah. And if you read enough hints, if this database got leaked, you can actually guess the password, because just look of all the passwords that look the same and look at the hints, and you can essentially guess it. All right, guys, so that's the second method. Obviously, also bad. Not as bad as the first one, but you can live with it. I mean, yeah, nobody care about your database and your authentication, right? If you're building like I don't know, system for your local community, right? You can use this method. But why? If you can actually salt the dang thing, you can salt it. So what is salt? So the third method is actually salting it. So instead of just taking the same text and generating a hash, which results in the same hash, which kind of look a little bit sketchy, what we want to do is instead is insert another factor, which is what we call a salt. A salt is just a random string that you store in the database as well as a third field, right? So if I query number 3 now, and you can see there's a field called salt. So we store the salt, the random value, and we store the hash as well. So now let's go to the register and see how it looks like. The register code, this is what we're going to do. The register code will query the authentication method 3, and what we'll do is hey, there's no this. Create a random salt, and think of this function as just, I don't want to show it because it will just generate a random string. Because we generate a random string, use that random string and save it in the salt of the database. There's a field called salt. But when you hash the password that the user gave you, take the password with the salt and hash those two together. So they are essentially unbreakable, right? But now, if you look at the database, even if two people have the same password, they will definitely not have the same salt, and they will definitely not, as a result, they will definitely not have the same hash, right? Pretty good method. A lot of work. You're forcing me to store another field, which I don't like, but yeah, that's a pretty good. Let's actually test it. Method 3, and I'm gonna make the code available for you guys, so don't worry about it. So now authentication method 3 is listening. Now when a query, there is nothing. If I refresh, let's do test and register. Oop, all right, I just have a breaking point. Let's remove it. And successfully, look at the database, query. What? Look at that, beautiful salt, right? Beautiful. So now if I create a user Paul and I register, technically they have the same password and you can log in, right? We're gonna go through the login code. We didn't go through that. But if I query, both of them have the same password, but look at that. They are different. So now we just made it harder on the hacker or the attacker, whoever got their hands on the database. We're making their life harder to actually guess the password. All right, that's good. We didn't actually go through the login code, so how about we go through it? The login code, we query the database. Now we actually this is not one query. This is now essentially one query, pull the results, and not just compare the number, because we need to do some client work here. we select star. Probably a bad idea, guys. Don't do that. You select only what you need, but I'm just testing. This is a tutorial, right? It's not a production code anyway. You know that probably. So we query that and we check that. Hey, all right. If there is no user, that this user doesn't exist, so we're gonna return this error. And by the way, I don't say user doesn't exist because we don't want to give the client hints about what the actual situation is. You always give it as vague result as possible, as just known, right? You don't give them, oh, by the way, the username is okay, but the password is wrong. You don't do that. Just try to make it as vague as possible. All right, so we get the password from the database, which is salted, right? The salted password. Now that's what the database have. We take the plain text password that the user gave us, and you might say, Hussein, why we're sending the password in plain text? That sounds a little bit sketchy. Well, not if you have TLS. You're absolutely fine. If you have TLS, remember, you're encrypted. That's why you always have to have HTTPS. And we talked about TLS. I'm going to reference the video here, right? So it's encrypted technically in the wire, so nobody can sniff your plain text password. So take that plain text password. Take the salt from the database because we query the database, the user salt that we stored, combine them, and if we got the same salted password, we are no longer salty. We can actually return a login successfully. How about that? All right, and this is pretty cool. So that's the third method. Fourth method, probably the most popular, bcrypt. There's a library called bcrypt, which essentially uses salt, but it is creating the salt for you and storing the salt in the resulted hash as it takes some part of the hash, few bytes, and store the salt there. So you don't have to worry about any of that stuff. How about we actually go through that? Method 4. So let's go through the register code as usual. Register code. When I register, we query the database if that user, right? And if we got no user, obviously we can create it. We use the bcrypt function. You give it the plain text password, and you give me how many times do you want to generate this salt? Because really, the randomness, guys, if you don't know, it's an unsolved computer science problem. You cannot really truly generate a random. People try. That's why you give some random number here. So we try as much as possible to generate a truly random number. But yeah, that's way above my head. It's some professors are still researching this stuff, right? Yeah, we get the hash, right? But the hash actually have a salt in it. How about that? That hash is the hash, and some part of it is actually the salt. So I don't have to worry about the salt because the salt is in the hash. Okay. Now I'm gonna go ahead and insert just the username and password. No need for an additional column. You're cool. And then just store these two pieces of information, the hash and that. And then the login, we can use the bcrypt function. We query, get the password, the salted password, which happen to have the hash and the salt in it at the same time. And if you give me this bcrypt.compare and you give me the plain text, and I can compare it with the salted password, which happened, this guy is the salted hash, and they're all combined together. So what bcrypt will do, it will take the first few letters or few characters and use it as a salt and do the same exact thing with what we did with method 3, guys. And we give you true or false. If it's true, login successfully. False, you are not authorized. You shall not pass. All right, how about we run this thing and test this thing? All right, guys. Guys, I'm gonna do, this is just the authentication part, guys. Authorization and access tokens. I'm gonna make a JWT specific video just talking about that. This is just the login, guys. A subsequent request is another story, right? All right, authentication method 4. And obviously we have only 2 columns, good. Now, refresh. I'm gonna create a user called test, and the password is also test. Register. Created successfully, and let's create a user called Paul, same password, register, And let's create a user Hussein and register. And obviously if I log in with the same password, I'll get an error. If I give sweet. Refresh and look at that. They are different, but they look very suspiciously the same, right? This is what I talked about. The first few characters are essentially the salt. And despite me using, looks this number 10 looks like we're using the same salt somehow. I don't know what is up to that. Let me know if I'm using this function incorrectly, the bcrypt. But nevertheless, they are different passwords. All right, so bcrypt, guys, bcrypt, right? That's the fourth method and the final method, right? And there are some services actually use this, by the way, guys. It's called Keybase. Keybase is actually one of the services that's not as what I have done here. It is using something like that, right? So the password is actually, it's up to you. You store the password, you give me the password, and I'm gonna decrypt everything you have. Even they don't know your data. They have no idea, right? So the method 5 is no password stored. So technically, you still need a database to store the encrypted stuff. How about we actually go to the register and see what code do we write here? And I'm using here essentially the symmetric key encryption algorithm to decrypt and encrypt with the user password, using the password as the key. Probably a bad idea, but this is just to demonstrate the possibility of doing things. So the register, we query and check if the username exists, same thing. If it doesn't exist, good. And I'm gonna encrypt the data, and I'm using the username's actual data, but think of it as just the whole, I don't know, the profile or everything, right? And I'm using the password as the key. That's the key. So encrypt with this, you're gonna get some encrypted data. Insert the username and the data, not the password, just the actual encrypted data in the database. So method 5 has actually two fields, user and user data. There's no password. We don't store the password. We just store the encrypted user data. And then we tell the user, hey, successful, else fail. And the login is very similar. You query the database, you get this encrypted data, but even the application itself doesn't really know what this is, right? So what it does is you take the encrypted data and you attempt to decrypt it with the supplied username password. And whatever you got there, you send it back to the user. If this function failed, I've changed it so it returns an actual error of the actual whatever happened during decryption. That probably say that, hey, I couldn't decrypt your data. That's what it means. How about we test this thing? Final thing. All right, let's test this thing. I'm gonna create a test and the password is test. I'm gonna register and probably I have a breakpoint. Yeah, that's what I thought. Just encrypt. And now I user created successfully. Now if I go method 5, query that final table, look at that. It's just a bunch of encrypted data. Nobody can actually decrypt this thing unless they try to brute force it. It's just data and the username. There's no password. So now, guess what? If you can log in, I am going to attempt to actually give you the results. I'm going to decrypt that thing. If I get decrypted, which I happen to decrypt it good, I'm going to send you that data. And I say, hey, this is what I have, which is the data is the test, which is the username in this case. How about if I supply the bad username, bad password? Log in. What we're going to get is an error. Let's show the error. This is exactly the error that the EAS algorithm throw at me, and I just throw it back at the user. Hey, bad decrypt. I couldn't even decrypt this thing. So guys, these are the 5 methods of authentication that I can come up with. What do you think? What is your favorite? Number 1, number 2, 3, 4, or 5, or even 6? Do you have more? Let me know in the comment section below, and stay tuned for more videos like this. I'm gonna talk about the access tokens and refresh tokens and JWT, and whether JWT is a good idea or not, why did we invent JWT, all that stuff in another video. It deserves its own video, to be honest. All right, guys, maybe Auth also, that's another video by itself. Authentication, Auth, Auth 0, all that stuff. We're going to talk about it in another video. If you enjoyed this video, give it a like, share it with your friends. I'm going to see you in the next one. You guys stay awesome. The code is below.